Welcome, learner, to STEM pathway, focusing on mathematics. Today we're looking at greatest common divisor, mainly abbreviated as GCD. The meaning of GCD is a divisor that is greatest and common for two or more numbers provided. So let us write that down. A divisor that is the greatest, but common for the two or more numbers provided. That is the true meaning of GCD. The name is greatest common divisor, but understanding this is key. So greatest common divisor means a divisor that is the greatest but common for the two or more numbers provided. Let us do an example. E.g., find the GCD of 24 and 16. Let us use this as an example. Now, because we are talking about GCD divisor, we realize divisors are also called factor. That's why the other name for this is called high common factor, HCF. So we look for factors for 24 and factors for 16. Let us start with the factors for 16 solution. 16 as 1, 2, 4, 8, and 16. 24 we have 1, 2, we have also 3, we have 4, we have 6, we have 8, we have 12, and we have 24. So we are going to look for a divisor after this, a factor, which is the greatest but common for the what? For these two numbers 16 and 24. 16 and 24. All the 1 and 1, it is common, but it is least. 2 and 2, so we have 1, we have 2. We look which is common first. 1 is common for the both, 2 is common, 4 is common, 8 is common. Now ask yourself, common factors here are 1, we have 2, we have 4, and we have 8. But we talk about divisor, which is the greatest but common for the two numbers. So, which is the greatest? 8. So, the GCD here, GCD of 16 and 24 is 8. But now this method is simple. But now the only challenge is you may be given 3 numbers and you may end up writing many. Or you may be given big numbers and you may end up writing a lot of numbers, a lot of factors, which may take a lot of time. Let us find the GCD of these two numbers using table format. This is now listing factors. Now let us use table format. Table format for the two numbers. We have 16, 24. So the first now which can divide 16 and 24 is 2. This is 8, 12. Again 2. This is 4. This is 6. Again 2. This gives you 2. This gives you 3. There is no number that can divide 2 and 3 at the same time. So we leave it there. They say GCD is 2 times 2 times 2, which gives you what? 8. And see, it is the same. So that's how you find the GCD, and that's how tested for GCD is. Now let us look at more example on GCD to know which is GCD and which is not GCD. Now get this. Divisor makes something that was so big to become small. Now look at this. Compare 16, 24, and 8. Realize 16 is greater than 8. 24 is greater than 8. And therefore divisor makes something big becomes small. So the talk about GCD, when you look at something coming from big to small, and the ones which are the bigger ones, you've been given their values, that is GCD. Let us look at an example. So that next time when you're looking at the issue of GCD and LCM, hautabahatisha tena, you get it right. Let us have this example. You may write it down. Let us have this example. You may write it down. You ask, there's a question I have here. The length of three wires were, the length of three wires were, the length of three wires were 30 meters, comma, we have 36 meters and 84 meters. They are told pieces of wire of equal length, pieces of wire of equal lengths were cut from the three wires, were cut from the three cut from the three wires. Then you ask, calculate the least number of pieces obtained. Calculate the least number of pieces obtained. One of the major mistakes students do when they see the word least, they start just doing LCM, not knowing they are asked to find GCD. So I want to give you a way for you to understand so that next time you don't fail in getting to know whether it is GCD or LCM. Now let us reason. It is reason. We have three wires. One is 30 meters, the other is 36, the other is 84. Then from these three pieces of wire, we obtain pieces of wire of equal length that were cut from this. So we have pieces of wire that were cut from these three pieces. You ask yourself, between these three pieces and the pieces obtained, which one is bigger? Obvious, we obtain pieces from a smaller item. So these three wires are big. So we have this one 30 meters, this one 36 meters, then we have this other one 84. So to mean for us to obtain pieces from this, then these ones are the ones which are big. Then the pieces we're obtaining is small pieces. So this is small. Get this? From big to small, something this that is big coming to small, we divide it, and that is GCD because of the division, dividing divisor. These pieces are big, we make a small pieces from the three big pieces, then we have to divide them. Therefore, we get a GCD of 30, 36, and 84. So we get GCD of 30, 36, and 84. So that we have here 2, here 15, here 18, here 42. 2 can no longer go into 15. Let us try 3. 3 can go here. Here it is 5. This is 6. Here it is 1. Then 4. There is no any other number that can divide this. So we have 2 times 3 gives us 6. But our unit of measurement were in meters. So one piece, a piece has 6 meters in length. But you ask, calculate the least number of pieces obtained. So from 30 meters, how many pieces obtained? You take 30 meters, divide by 6 meters gives you 5 pieces. Because one piece, 60 meters, 6 meters is one piece, therefore 30 meters will be 30 meters times 1 piece divided by 6 meters, 5 pieces. Then 36 meters divided by 6 meters, this gives you 6 pieces. Then we have 84 meters divided by 6. This gives you 14. This gives you 14 pieces. Therefore, total pieces we have are 25 pieces, of each length being 6 meters. That's how you do it. So in our next lesson, look at LCM, then you look at further examples of GCD and LCM. See you in the next lesson.